in this example we will say how exactly we can solve SJF or shortest job first scheduling with the mode non-preemptive one. Okay, with the non-preemptive mode. Let us take some processes, say for example process number, say for example 1, 2, 3, 4, say 5 if this is the case, and the arrival time for the processes are, say for example 0, 1, 2, 3, 4, and the burst time, say for example 3, 2, 1, 2, 5. If this is the case, if this is the data given in the question, then how can we solve this? So okay, now the first thing is we have to create the Gantt chart. Fine. So based on the Gantt chart only we can visualize how exactly we can deal with the number of processes. Fine. So the first process is nothing but P1, P2, P3, P4, P5, total 5 processes. The first one is P1. By default this process will come to the queue, so the arrival time is 0. Fine. Next P1. Now how long it is going to run? It is going to take 3 units, isn't it? 3 units. So 3, 0 plus 3 is 3. So P1 will execute up to 3 units. Fine. Now what is the next process? Now as this says shortest job first, okay, the first process is by default it comes to the queue, but after that it will check which has the minimum or short job. In these things the shortest job is this one, isn't it? P3 or process 3. So this process 3 will come to the queue. After P1, P3 will come to the queue. And what is the burst time? 1. So 3 plus 1, so 4. It will finish. P3 will be finished. After that, what is the second or the minimum shortest time, which will be the minimum shortest time? So it is both P2, P4, isn't it? Now P2, P4, again you are having this dilemma, isn't it? So both the process has got same burst time. Now what happens? In the previous video I said if the burst time or burst CPU cycle is same, then it will again go for FCFS fashion, isn't it? FCFS fashion, isn't it? Now in that case P2 has to come first, isn't it? The arrival time of P2 is 1 and arrival time of P4 is 3. So obviously this will be considered. P2 will be considered. So P2 will come to the queue, and what will be the burst time? It is 2 unit. 4 plus 2, 6. Fine. Now the remaining are these two processes, 5 and 2. Obviously the next process will be P4 because it has got lowest or shortest burst time. So P4 it will execute for 2 units. So 6 plus 2 is 8. Now last but not the least, P5 will be the last process in the queue, and 8 plus 5, 13. Fine. Something like this it will happen. So don't get confused. In this case the first process will, obviously this will be the first process, and first process will come by default, it will come to the queue. In the Gantt chart it will be the first process, and it is the arrival time is 0, so it is starting from 0 and it requires 3 units of time for the complete execution. P1 requires to come execute completely, it requires 3 units. So that is the reason why 0 to 3. So P1 takes that. Then after that it will check, the algorithm will check which is the shortest burst time, which process has got the shortest burst time. That process will be called to the CPU for the execution. Now once we are ready with the Gantt chart, what will be the next step? Directly we are filling up the rest of the details. That is nothing but CT, completion time. You can ignore this. Just for example purpose I have written FCFS. So CT, what is the CT or completion time of process 1? It is 3, correct? What is the completion time of P2? P2 is 6. What about P3? P3 4. What about P4? P4 8. What about P5? P5 is 13. Something like this you have to prepare the chart. Fine. So it is not in ordered way. That is the reason why while writing the CT you have to, or completion time, you have to be much careful, or you have to be very careful before taking the data. Once we get the completion time, then we can go for TAT, or turnaround time. Now how to calculate the turnaround time? That is nothing but difference between CT and AT, isn't it? 3 minus 0 again, 6 minus 1 5, 4 minus 2 2, 8 minus 3 it is 5, and 13 minus 4 it is nothing but 9. Fine. Now we have received a TAT, or we have calculated TAT. Now the next thing is calculating WT, or waiting time. Now what is the formula to calculate waiting time? It is nothing but the difference between TAT and BT, correct? Turnaround time and burst time. So what is the difference? It is 0, 5 minus 2 3, 2 minus 1 1, 5 minus 2 3, 9 minus 5, how much? 9 minus 5 is 4. Fine. So you have obtained some values. Now the same procedure, if they are asking for average, then add up all the detail, divided by 5, and whatever the answer you get, that will be the average of waiting time. And if they go for calculate the average of turnaround time, then again add up all this detail, divided by 5, and whatever the answer you get, you can write. Why divided by 5? Because total number of processes are 5. If the total number of processes 3, then add up 3 details by 3, something like that. Normal procedure. You have to follow the normal procedure for the calculation of this average values. Fine. Did you understand? So this is one of the example. Let us take one more example. Fine. Let us take one more example here. Say the process number. Let us go for the first process number. Now next AT, arrival time, and then BT, burst time. Say for example there are 4 processes. Say for example 1, 2, 3, 4. Fine. Now arrival time of first process is, say for example 1, 2, 3, 4. Let us take like this. Fine. Let us take the random data or something like this. So the burst time will be, say for example, say let us take 8, 2, say for example 3, next 5. Some random data. Let us take some random data for the explanation. Fine. Once we get this particular example, now we have to prepare the Gantt chart, isn't it? We have to go for the Gantt chart. So what is the first process? The first process is P1 or 1. So arrival time is 1. So the burst time is 8. So first process is P1. It is coming at unit 1. So now from 0 to 1, the slot is empty, isn't it? You don't have any process to run, correct? Now at unit 1, process 1 will come, or P1 will arrive. Fine. How much time it will take? It will take 8 unit. So 1 plus 8, it is 9, correct? You should not write 8 here. See, here we are writing directly 3. Why? Because we are starting from 0. 0 plus 3, correct? 0 plus 3, 3. But in this case we are starting from 1. So 1 plus 8, so it is 9. So up to 9 P1 will execute. Now algorithm will check which is the shortest one. So shortest one is P2 with the burst time 2, isn't it? So next process will be P2. So up to 9 plus 2, 11. So up to 11 unit this P2 will run. Okay, this also finished. Now in these two, which is the shortest one? P3. So here you don't have any sequential, it will come, so you don't have any thing to do. But in this case what it was like, P1, P3, P2, P4, P5. So any fashion, you based on the data, any fashion you can receive. It is not like something is fixed. Okay, based on the data you have to calculate. Fine. Now after P1, P2, P3, okay, P3 finishes at 11 plus 3, so it is 14, correct? Now which is the last process? Last process is P4, 14 plus 5, 19. So this is the ultimate Gantt chart. Once we receive this Gantt chart, we can go for completion time, CT. Fine. Completion time of P1 is, it is 9. Completion time of P2 is 11. Completion time of P3 is 14. Completion time P4 is 19. Fine. So this is the data you received. Now once you receive this completion time, then you can go for turnaround time. Now how to calculate turnaround time? Same formula. There is no changes in the formula. Difference between completion time and arrival time. It is 8, 9, 11, 19 minus 4 is 15. Fine. This is turnaround time. This data is turnaround time. Now what is the next thing? Waiting time, isn't it? Next thing is calculation of waiting time. How to calculate waiting time? The difference between turnaround time and burst time. So 8 minus 8, it is 0. 9 minus 2, 7. 11 minus 3, 8. 15 minus 5, it is 10. Fine. These are the data. You can cross verify. Waiting time of P1 is 0 because whenever P1 arrived, so it is directly given with the processor. It did not wait anything, so 0. Now why it is 7? Waiting time of P2 is 7. So arrival time of P2 was 2, but it given its time at 9, isn't it? So 9 means it was 2, 9. The difference between 9 and 2 is 7. Correct. Now arrival time of process 3 was 3, but it got the CPU at 11. The difference between 11 and 3 is 8. So like this you can cross verify whether the answer is correct or not. Now again, if the question is to calculate the average, it is add up all the details, divide by 4. Why? Total number of processes. Now if they are asking for average of TAT, add up all this, divide by 4. Whatever the answer you receive, that will be the average of TAT and waiting time. So something like this you can solve. You can take any data based on that. If you want, say if you want to try to solve this example, say process number is like 1, 2, 3, 4, 5, 6. Arrival time, say for example 2, 3, 5, 6, 7, 8. And burst time, say for example 3, 7, 5, 2, 1, 8. So try to solve this. Fine. Okay, so like this you can take any random number, random values, try to build the Gantt chart, try to calculate the things. Okay, try to fill up all this data. Okay, if you get any doubt, you can get back to me. So try to solve this problem. If you have any doubt, you can get back to me. Fine. In this case, how to calculate the average? It will be like waiting time. If you want to calculate the average waiting time for this particular problem, it will be like add up all the details of WT or waiting time, divide by 6, isn't it? Total 6 processes: P1, P2, P3, P4, P5, P6, something like that. Okay, try to solve this. If you get any doubt, you can get back to me. Okay, thanks for watching.